An echo is simply a reflection of a sound wave, usually at a solid surface, but really it can happen any time the sound wave moves from one medium to another. It is a reflection, so it follows the usual rules, but we're only going to think about straight reflections here, where the sound wave goes back the way it came. Here's a wall and two students standing 480 meters away from the wall. One student makes a loud sound, and the other student starts the stopwatch. When the student hears the echo, they stop the stopwatch. Let's say that the time taken is 2.82 seconds, and the distance that the sound travelled is 480 plus 480, which is 960 meters. That means the speed of the sound wave must be, speed is distance over time, which is 960 over 2.80, 340 meters per second. So that's a handy technique to measure the speed of sound. What's often more useful though is to find a distance. I like the example of finding a crack in an aeroplane wing. It's pretty important to know if cracks are growing. Now there will be cracks, by the way, there always are. What's important is if they are getting bigger quickly, because a big crack leads to a wing falling off. Anyway, we know the speed of sound in metal. For aluminium, it is 6,320 meters per second. That's much faster than the 340 meters per second in air. As a rough rule, if sound is 340 meters per second in air, it's around 5 times faster in liquids and 5 times faster again in solids. So the speed is 6,320 meters per second. If we send in a pulse of sound and start a fast timer, then use a microphone to stop the timer when the echo returns, we can easily measure the time taken for the sound to travel to the crack and back. And let's say it is 32 microseconds. Speed equals distance over time, so distance equals speed times time. That's 6,320 times 32 times 10 to the minus 6, which equals 2 meters. This is the total distance travelled, so the crack is 1 meter into the aluminium. This technique is used for cracks, for imaging babies in the womb, for sonar, and many other applications.